Good afternoon, students. Welcome back once again to the mathematics class. In the last class, we have discussed that is base theorem. It is exercise 13.3 problems based on base theorem. All the examples are based on what? Base theorem only in exercise 13.3 we have completed in the last lecture session, right? So in today's lecture, we are going to study a new concept. It is random variable and its probability distribution. Random variable and its probability distribution, right? So now already you know what is sample space and a random experiment, right? So heading is random variable and its probability distribution. So before going to start the random variable, we have already learnt about random experiment, right? What is random experiment? And formation of sample space also. If you get a random experiment, then what is the sample space of that? Or do you know how to find the sample space? In most of these experiments, we were not only interested in the particular outcomes that occurs, but rather in some number associated with that outcomes, as we can see the experiments. For example, in tossing two dice, we may be interested in sum of the numbers on the two dice, and in tossing a coin 50 times, we may want the number of heads obtained. So, like this, the experiments are there. So, let's see the definition for random variable first. Definition of this random variable, right? What is random variable definition? Let's see. A random variable is a random variable is a real valued function. It's a real valued function whose domain is whose domain is the whose domain is the sample space of a random experiment, right? What it says here, usually a random variable is nothing but it's a real valued function whose domain is the sample space. Already you know the what is sample space and domain also, right? In a function chapter you have studied a domain, right? So domain is the sample space of a random experiment. For example, let's see what is exactly a random variable we can conclude from this example. So let us consider the experiment of tossing a coin two times, right? We are tossing a coin two times, or you can take a two coins are tossing also, right? So tossing a tossing a coin two times in succession, right? So the sample space of this experiment is what? S equals to 2 times means head tail head, tail head, and finally tail. There are four possible outcomes what we get in a sample space when coin is tossed two times in succession. So here, if x denotes capital X we are taking, if x denotes the number of head obtained, x denotes the number of head obtained, number of head obtained, then x is what? Then x is a random variable. Then x is random variable for each outcome. Right here x denotes what? X we are denoting a random variable. So what where x denotes here, let's see. If x denotes the number of heads obtained, then x is a random variable we are saying here for each outcome. Then its value is given. Let's see the value for heads. The value for heads, right? So here x of HH, x of HH which is equals to 2, x of HH which is equals to 2, comma, x of HT which is 1, number of heads obtained we are seeing only here 2 heads, we are taking 2, 1 head, taking 1, x of TH which is also 1, and x of TT which is nothing but 0. So here the random variable what we are getting here, x of HH is simply a random variable, is nothing but this only. When x has 2 heads we have which is equals to 2. When x of HT we have 1 head. When x of TH we have only 1 T. When x of TT there is no head, then we can say x of TT which is equals to 0. So more than one random variable can be defined on the sample space, right? For example, let y denotes, similarly here only, one more time we can say, already we have taken here x. Now, for example, let y denotes the number of heads, the number of heads minus number of tails for each outcome of the sample space. Yes, right? So let's see what we get here. At y of HH is head minus tail. 2 head minus 0, that is 2. Next second one what we get here, y of HT 1 head, 1 tail 0. Y of TH 1 head 1 tail 0. Y of TT, that is 0 head minus 2 tail, that is minus 2. So what we can say here, it's a real values we are getting here from the function f. Here simply we can say it is f. It's a function where the outcomes are what? They are real numbers, right? They are real range, right? So here what we get here, it's a sample space yes. From this yes, what we are getting are real values. 2, 0, 0, minus 2 doesn't matter. Minus 2 is also a real value here, right? So which is nothing but Thus, what we can say here from these two examples, x and y. Thus, x and y are two different random variables defined on the same sample space. Thus, x and y are two different random variable defined on the sample space, right? So which is nothing but our random variable, right? Now it's a probability distribution. What is probability distribution? Let's see. By an example, uh, by taking an example, we can see. First, let us see the definition for probability distribution. It is the definition for probability distribution. Later on, we can see an example. So here, the probability distribution, the probability distribution of a random variable x is the system of numbers. Probability distribution of a random variable x is the system of numbers, that is x. Here p of x is nothing but our probability distribution. For example, if we have x as x1, x2, so on, xn in general it is, then probability distribution is p1, p2, so on up to pn, where where p equals to, sorry, where I equals to so which is nothing but what here, x and px, not necessary. So here the probability distribution of a random variable x is a system of numbers where x equals to x1, x2, so on up to xn, and the probability distribution what we can have with respect to the sample space, it is p1, p2, so on up to pn. So let's see an example. Based on this, we can conclude very easily what is probability distribution. Let's see an example. See, for example, we can understand both the examples here for random variable as well as probability distribution, right? So let's see heads in a simultaneous toss of 3 coins. Example is what? Finding random variable as well as probability distribution. For example, we can take here heads in a simultaneous toss of 3 coins. 3 coins, right? So first let's see what will be the sample space for this. Heads in a simultaneous toss of 3 coins means what we can have here. We have the sample space S equals to when coin is tossing 3 times. Head, 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 tail, head, tail, head, tail, head, head, and tail, 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 head, tail, head, tail, head, tail, tail, right? So there are 8 sample points we have in a random experiment tossing a coin 3 times, right? So now here, what will be the random variable here x? X is 0. Heads in a simultaneous toss of 3 coins means we can have associated outcomes is 0, 1, 2 and 3. 3 outcomes we have here, right? So now P of x, that is probability distribution, what we have here? Probability distribution for, let's have a box for this one. So it is nothing but our random variable. Random variable is denoted by x, right? Whereas number of heads, what we are going to get here, either we can get no heads, it is 0, 1 head, 2 tail, 2 head, 1 tail, and all the 3 are heads, right? So in that case, the probability distribution for 0, what we have for 0 means only 3 tail. No head means the probability distribution is what? Favorable outcomes is only 1 divided by total outcome, right? It is now total 8 outcomes are there. The sample space which is equals to how much sample points are there? 8 sample points are there, right? So now here it is 1 by 8. Only one sample point is present in this. There is no head, right? 0 stands for what? No head. Now 1, only one head. Only one head, how much? 1, 2, and this one is 3. Only one head. Total 3 possibilities are there. 3 by 8. And similarly, 2 heads. For 2 heads, one non-head, it means it is tail. 2 heads, 1 tail. 2 heads, 1 tail. 2 heads, 1 tail. It is also 3 by 8. And finally, all the 3 are heads only. It is 1 by 8. So which is nothing but our probability distribution. That is x, it is P of x, sample point and probability distribution. Similarly, if you want to find the mean and variance and standard deviation of this function, this given function, the statement that is heads in simultaneous toss of 3 coins. So let's see for that. What is formula for mean? Mean formula is summation x into px. Summation x into px. It is nothing but x into px. Just multiply here. What we get? X into 1 by 8 is 0. 1 into 3 by 8 is 3 by 8 plus 2 into 3 by 8 is 6 by 8 plus 3 into 1 by 8 is 3 by 8. So which is equals to how much we get? It is 12 by 8, right? What we have here? The value is 12 by 8. So that is nothing but x into px. X into px is 0, 3 by 8, 6 by 8, 3 by 8, right? Which is nothing but our mean value. So now variance that is nothing but x. The formula for this, summation x square into px minus summation x into px whole square, right? So what we'll get? That is x square value. So I can remove this here. We'll write this side. That is mean value. Mean is 12 by 8. Variance is, we have to find that one, right? So I'll remove this to write a table here. So now we can find first x square here. Later on we can find variance value. So what we get? X square is 0, 1, 4, 9, right? Which is nothing but x square. So now x square into px, x square into px value, x square into px, it is 0, 3 by 8, 12 by 8, and finally what we get? 9 by 8, right? So just substitute in the formula, what we get? Let's see. X square px value, summation of 0 plus 3 by 8 plus 12 by 8 plus 9 by 8 minus of summation x into px 0 plus 3 by 8 plus 6 by 8 plus 3 by 8 whole square. So what will you get here? 3 plus 12 plus 9 by 8, and similarly minus 12 by 8 whole square. So here what we get, it is 24 by 8, which is nothing but 12 by 8 means 3 by 2 whole square means it is 9 by 4, right? 12 plus 3 is 15, 15 plus 9 is 24 by 8 minus 9 by 4, right? So from this what we'll get here? 3 minus 9 by 4. So what we'll get here? 3 by 4 it is equals to 3 by 4 will be the variance. Got it? Similarly, if you find the standard deviation, what is the standard deviation here? Standard deviation is nothing but root variance, which is nothing but root 3 by 4, which can be written as root 3 by 2 is nothing but standard deviation for this given statement, right? So finally, what will you get when the probability distribution will be? So here what we have, the condition for probability distribution, what you have, which is nothing but the sum of all the terms when you add you will get 8. So this probability distribution, what we are saying, the sum p of xi, what we are taking, the sum, this p of x, the sum of these terms, if you add, then you will get which is equals to 1 only. So let's check. 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8. 3 plus 3, 6, 6 plus 1, 7 plus 1, 8. 8 by 8 which is equals to 1. So sum of all the samples, it is 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8, you will get finally the value which is equals to 1 only, right? So usually the probability distribution is positive value. The probability distribution we have the positive value, that is in general we can say summation p of xi, x1, x2, x3, so on, that is p of xi, which is nothing but which is equals to 1, and p of xi which is greater than or equals to 0 only. We cannot get negative values here, right? In a probability distribution. Got it? So which is nothing but random variable and probability distribution, and similarly we have discussed mean and variance also, right? So mean and variance are removed, deleted this year. They are reduced the syllabus by removing mean as well as variance. But just for your knowledge purpose, I have explained the formula for mean and as well as variance, right? So with this, we will conclude our today's lecture. The next lecture we will discuss the exercise 13.4. Later on, Bernoulli's trial and binomial distribution is there. Last concept in the probability. So later on we will conclude the probability chapter, right? So the next class we will start